Hi, in this video we will learn what is displacement and distance traveled by a moving object along a straight line, and how we can compute these two quantities knowing the velocity of the object at any given point. Well, remember that when we have an object which is moving on a straight line, so an object is moving along. Let me write a real line or a straight line here, but specifically what we mean is on a real line. So we have the unit of distance and everything. Then we have this function called position function, which has all the information we want to know about the movement of this object. What is this? At any given point, at any given time t, pt says where is the object at that point. So pt. And well, when you have that, we know the velocity of the function, in other words, rate of change of the function p is the same thing as the velocity of the object at any given point. So the velocity of the object, in other words, p prime at t is equal to vt, velocity at time t. And what we can also have a net change of the function p, the position function p on an interval ab. What is this, guys? So this object is moving along the line, and net change, you know, that is p at the last moment, so p at b minus p at a. But this guy is the same thing as displacement of the object on the time interval AB. So you just look at the starting point and end point and see how much the object is displaced during this time. Also, one can ask about another thing, which is distance traveled by the object on the time interval AB. Well, here you have to note the distance, the difference between distance traveled and displacement. You see, if an object starts from this point, goes along, and then comes back on the same line and stops it here, for such an object, a displacement is 0, because when you look at the end point where it started, end point, there's the same point, there's no displacement. But the traveled distance, well, it definitely traveled all the way here and then went back, so it is something not a 0. It traveled, but the displacement was 0. So based on the net change theorem, we know that the integral of the velocity on AB dt is going to be displacement. displacement of the object on the time interval AB. But if you're looking for a distance traveled by the object on the interval AB, the integral you have to consider is a little bit different. The function, the integrand, is not the velocity, but its absolute value. So if you're looking for displacement on an interval, you just integrate the velocity itself. But if you're looking for distance traveled, you have to integrate absolute value of the velocity. Let's see this in some examples. Oops. I believe I have two examples here. Yes. Find displacement and travel distance of a moving object whose velocity is given. So velocity of the object is here. We're looking for displacement on the interval 0, 2. We know that this is going to be 0 to 2 of the velocity function. Well, velocity function is a polynomial, so this is t squared plus 3t minus 4 dt. And if you compute, so this is an antiderivative, t cubed over 3 plus 3t squared over 2 minus 4t, go from 0 to 2. And what it will give us is 8 over 3. I'm plugging in the upper value, plus 4 times 3, 12 over 2. And then we will have minus 8. Yes. And while if you simplify this thing, you notice that this is 6 minus 8 is negative 2. Negative 2 plus 8 over 3. This will be 8 minus 6 over 3, which is 2 over 3. Very nice. How about distance traveled? On the time interval 0, 2. This time it is again integral 0 to 2, but not the velocity, but its absolute value. When absolute value comes in, you have to make sure you know where the function is positive and where it is negative, t squared plus 3t minus 4. So a sketching function can be helpful because we know how to sketch this function. It is nice to have a sketch of that. This is parabola looking upward, passing through negative 4 and 1. In other words, it will be from 0 to negative 4. The velocity is going to be positive. Then from 4 to 1, it is going to be negative. And from 1 to plus infinity, it's going to be positive. And as you can see, this goes from 0 to 2. So it has both positive side and negative side. So to evaluate such a function, we have to make sure that first we separate the integral on intervals for which the function is either positive or a negative. So here we have t squared plus 3t minus 4 dt. Okay, we know that on 0 to 1 the function is negative, so absolute value will be negative of that. And for the the interval 1 to 2, it is positive, so we can leave the function as it is. Okay. Well, then I need more space, sorry about that. Then we need to use antiderivative here, negative t cubed over 3 minus 3t squared over 2 plus 4t, go from 0 to 1, plus, yes, plus integral, which is again t cubed 3 plus 3t squared over 2 minus 4 from 1 to 2. Well, evaluate these values. You will get different values. For example, if you plug in 1 there, this is negative 1 over 3 minus 3 over 2 plus 4. Minus, if you plug in 0, that will be 0. Plus, if you plug in 1, this is 1 over, I have to plug in 2 first. So this will be 8 over 3 plus 12 over 2, which is 6 minus, there's a t there, 4t, 4 times 2, this is 8, minus, when you plug in 1, this will be 1 over 3 plus 3 over 2 minus 4. And then you can do the work, you simplify. My notes show that this value must be 5. And as you can see, the distance traveled is way different than the displacement. A difference between these two also can be said this way, that displacement can be a negative number, but distance traveled is always positive number because of that absolute value. Let's do another example. Again, the velocity is given, so displacement on 0 to pi is the net change, so it will be integral of the velocity function. Here, this antiderivative of this is sine t, go from 0 to pi, and this is sine of pi minus sine of 0, which is equal to 0. But travel distance on the 0 pi, we have to make sure that we have integral of absolute value of cosine t dt. While checking the graph of cosine t, you will see that this can go from 0 to pi over 2. Cosine t on that interval is positive. And then for the interval pi over 2 to pi, cosine is negative, so I will need to multiply a negative sign to that to get a positive number. So this will be sine of t go from 0 to pi over 2 minus sine of t go from pi over 2 to pi. And if you plug in the values, this will be 1 minus 0 minus sine of pi is 0 minus sine of 1 is 1, and you add, that's 2. So it traveled 2 units, but the displacement is 0. So it means that the starting and end point are the same thing for this object. Okay, so these physical meaning and how to compute each one was the topic of this video.